All right, hi everybody. So you have made it. We are at trigonometry, and this is one of the best lessons of the year. I think that you will love trigonometry. So I know it sounds intimidating, and you've probably heard horror stories about it, but first of all, what we're doing is not that bad, and it's not that bad anyway. So trigonometry is the title of our lesson today. And I do need to mention that right now, we are just doing an introduction, and we are doing right triangle trigonometry. So there is a difference. So just to clarify that up front. Okay, so first thing, we are dealing with right triangles. So I'm going to start by making a right triangle. And a little while ago, we looked at a video when we were doing similar triangles, and it ended up with Pythagorean theorem. But I mentioned at the time that if we want to call this triangle ABC, it looks like this. The C is always the right angle, and then the side that's across from the C is lowercase c. And the side that is across from the A is lowercase a. And then the side that is across from angle B is going to be lowercase b. So that's a setup of the right triangle. Now we know about right triangles that this side, which is the longest side, it's the one that is opposite from the right angle. This has a special name, and that is the hypotenuse. So that still holds true, even in trigonometry. So now what we're going to do is look at names for the legs. We know that A and B, those are the ones that make the letter L here. We know that those are the legs of the triangle. But for our trigonometry purposes, there are also going to be something else. Oh, Maisie's here. Oh, hi, Maisie. Okay. Hi. Say hello. There's Maisie. Very nice, very nice. Okay. All right, so if we are looking from the perspective of angle A, all right, so I'm going to say this angle right here. If we are looking from this perspective, this angle right here, or sorry, this side right here is always the hypotenuse. But what is going to be different is the name of what we might call this side right here. From this angle, this side is the side that is opposite. So I'm going to call this opposite. And from this angle, this side right here is the side that's right next to it. And next to is kind of common. For official purposes, we call it adjacent. So if we are looking at the perspective of this angle right here, then this side is opposite from the angle, and this side right here is adjacent to the angle. So what you might be thinking is, well, that's not going to be the same thing if you were looking from over here, which is absolutely correct. So I'm going to say if I was over here at this angle, which we'll make that a little bit bigger so you can see it. So if we were looking from the angle B, then this side isn't the adjacent one. From this angle, this side is the opposite side to the angle. This is still the hypotenuse, but this side, compared to this angle, is right next to it. So this one would be adjacent to angle B. And you might be wondering why that's important, and it's very, very important because the basis of trigonometry is looking at the triangle at the opposite sides, the adjacent sides, and then the hypotenuse. All right, so first off, you might even be wondering what the heck trigonometry is. So trigonometry is giving us the ability to use information about the angles to get information about the sides, or vice versa, combination of it. So right now, you guys know that the three angles of a triangle would add up to 180 degrees, but that doesn't help you with the sides. And then you guys know that you could use Pythagorean theorem, like let's say you knew side A and B. You could use Pythagorean theorem to figure out side C, but that doesn't help you with the measurement of the angles. So what trigonometry is going to do is it's going to relate those two measurements between the angles and the sides together. All right, so we have what we call trig functions, and there are 3 basic trig functions, so that's what we're going to make a list of now. So these are our trig functions, and you have probably seen these on the calculator, and now you're going to be able to get to use them. So trig functions, there are 3 of them. We have sine, we have cosine, and we have tangent. Now, I have no idea who decided on these names. It wasn't me, but I can explain it to you. So, sine, what we use for that, just for emphasis here, is S-I-N. But when we pronounce it, it is sine. All right, cosine is C-O-S, but when we see that, we still pronounce it cosine. And then the last one is tangent, which we use T-A-N, but that is pronounced tangent. So to say sin, cos, and tan makes it sound like you don't know what you're talking about, because when we see these 3 things, this is sine. Oh, there's Maisie again. Hi, Maisie. This is sine, this is cosine, and this is tangent. Hi, Maisie. Okay, so now it's important for you to understand how this relates to our triangle up above. So what we're going to do is we are going to make a fraction for each of these trig functions. And the fraction is going to use the angles and the sides from above. So first up is sine. And the sine from a certain angle. So what we're going to say, let's see how, well, I'll go back to the blue. All right, so let's say we have, oops, the sine of the angle is going to be the opposite side. So right in here, we would put the angle measurement. So the sine of the angle is going to be the opposite side over the hypotenuse. So as you can see, what we're doing here is we're relating the angle measurement to the sides of the triangle. So we're now going to have angles and sides all in one problem. All right, the cosine, which we would say the cosine of the angle measurement, is going to relate the adjacent side to the hypotenuse. And then the last one, which is the tangent. So the tangent of the angle measurement is going to relate, I don't know if you want to make a guess, it's going to relate the opposite over adjacent. So a few minutes ago I mentioned that what's special about trigonometry is that it allows us to relate the angle measurements to the sides of the triangle. So that's how we're working on it right here. All right, now you might be thinking, how in the world am I ever going to remember this stuff? So somebody, it was not me, came up with a very, very, very cool way of remembering this information. And it is, I'm going to slide this up a little bit, SOHCAHTOA. SOHCAHTOA. Now, SOHCAHTOA was not an Indian. There's no history here. SOHCAHTOA is just an acronym to help us remember the 3 basic trig functions. And the way it works is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So SOHCAHTOA, whoever came up with this, is absolutely brilliant as a way to help all of us remember the 3 main trig functions. Okay, so next up, you're probably trying to figure out how does this help us out, how would we work out a problem, that kind of thing. So we are going to move on to example 1. So turn this over. All right, so first up, so in the problems that we are doing, we are always going to be starting with a right triangle. So first thing I'm going to do is to draw a right triangle. And I'm just going to use standard ABC here. All right, now for this problem, I'm going to tell you that this side is 5 and this side is 12. And what we're going to do right now is figure out what this side is right here. Well, here again, we know 2 of the 3 sides of a right triangle. So since we know that the 2 legs are 5 and 12, that's going to be our A and B values. So we could say that 5 squared plus 12 squared equals C squared. So that would be 25 and 144, which adds up to 169. And I know that the square root of 169 is 13. So I know using Pythagorean theorem that the side right here is 13. All right, well that's fantastic. But now I want to figure out what the angles are. And I know this angle right here is 90 degrees. And I know that A and B angles added together would have to equal 90 degrees, but that doesn't help me out with what each one is. They don't have to be 30 and 60. They don't have to be 45 and 45. They could be 31 and 59. So this is where trig comes in. So what we could do, if we wanted to figure out what angle A is, so let's say we want angle A, then what I could do is I could use the sine function from angle A. So the sine from angle A, now remember that we're dealing with SOHCAHTOA, so the sine is going to be the opposite side over the adjacent side. Sorry, over the hypotenuse. So from angle A, the opposite side is 5. The hypotenuse is 13. So then I can go to the calculator, and we're going to do that in a little bit, type this in, and that will tell me how big angle A is. All right, let's say from angle A we wanted to do the cosine. So if we are at angle A and we're doing the cosine is going to relate the adjacent side to the hypotenuse. So the cosine from angle A, the adjacent side is 12, the hypotenuse is 13. So I know that the cosine of angle A would be 12 over 13. So again, you grab the calculator and you work that one out. All right, let's say we wanted to do the tangent from angle A. So the tangent from angle A, the tangent function is the opposite side over the adjacent side. So from angle A, the opposite side would be 5. The adjacent side is 12. And the reason why I know that the adjacent side isn't the 13 is because that's the hypotenuse. All right, so this is the end of the first video because we're almost out of time, so I will continue in part 2.